let's practice going through the steps to actually constructing confidence intervals. There's going to be kind of 3 overall steps that we want to go through here. First thing we should always do is check conditions. Basically, we need to make sure that we have a bell-shaped curve for our sampling distribution so that we can use those critical z-scores. Then our second step would be to actually construct the interval. So we'll use our formula, the p hat plus or minus z star times our standard error, and that will construct our interval for us. In fact, I'll be more descriptive with our standard error there. It's the square root p hat q hat over n. So we'll plug in the values that we know there and then find that lower bound and upper bound. So when we construct the interval, we should end up with lower bound, comma, upper bound for an interval. Then once we get the numbers out, that third and last step would be to write a conclusion. We need to make kind of a sentence summary of what did we find, putting together our confidence level, the values we found in the interval, along with the description of our population proportion. So here we have a sample of 166 adults, and they were asked whether or not they were baseball fans, and 46% said that they were. So the pieces of information that we have here, we have a sample size of 166. We have a sample proportion from that sample size that we took there, so 0.46. And if we have p hat, then we also have q hat by just taking 1 minus the 0.46, which would be a 0.54. So from that first sentence, we get those 3 pieces of information. So first example here says to construct a 99% confidence interval. So as soon as you see that 99% confidence, we can grab that z star that we found in the previous video. We want to use that 2.5758. So with that, we have all of the pieces to our interval. Before we start plugging in and calculating, we need to check our conditions. So first, check conditions. So we should have independence. And if we take a random sample of people, then they're not going to influence each other's answers. They'll have, whether or not they're a baseball fan, will be independent of each other. So we'll have independence. Randomization, they didn't say it's a random sample, but we'll go ahead and assume we're good there. And then the success failure, what we need to do is take 46% of 166 and take 54% of 166. And make sure those values are larger than or equal to 10. So this is about 76, and this is about 90. So with that, both of these are more than or equal to 10, so we're good there. So we checked our conditions, and we can move forward. But if we fail any of those conditions, then we can't find this confidence interval for a proportion, because basically it means we don't have a bell-shaped curve, or at least we can't assume we have a bell-shaped curve. We can't move forward. But we passed those conditions, so now we can construct the interval. And now we go to use that formula above. So we take our sample proportion, which is 0.46. We're going to take plus or minus, and then 2.5758 times the square root of 0.46 times 0.54 over 166. And with this, it's good to just plug in everything on the right-hand side of the equation, and then you can get a single number that you're going to add and subtract with. So over here, we're going to have a 0.0996. Be sure to keep things to 4 decimal places as much as possible for accuracy. And then what we're going to do is split our equation into the subtraction of the 2 values and the addition of the 2 values to get our lower bound and our upper bound. So if we subtract 0.46 minus 0.0996, that'll be a 0.3604. And upper bound, if we add 0.46 plus 0.0996, that'll be a 0.5596. So with that, we found our confidence interval. So we have the numerical values. Then the last thing we need to do is make a conclusion. So where we could start for our conclusion is just starting with our confidence level. We found this interval with 99% confidence. So you could say with 99% confidence. And then we want to relate this range of values to our population proportion. So our sample proportion is this proportion of 166 adults who were baseball fans in 2012. What we want to do is talk about the proportion of all US adults. In fact, the wording is in the question itself. Make the interval for true proportion of US adults that are baseball fans. And we should probably keep this in 2012 since that data is a little old there. But we want to talk about this proportion of all US adults and not just the 166 adults. So we have this wording for our population proportion, and this proportion for all those US adults is between this lower bound of 36.04% to 55.96%. So for our wording, we could say something like 36.04% to 55.96% of US adults were baseball fans in 2012. And that would be our conclusion. We have our confidence level, the range of values, and then the wordings in terms of our population proportion. So those are the steps we want to go through for every confidence interval. Let's see if we take this kind of same example, but we change our confidence level. So now we're looking at an 80% confidence interval, which means now we'll use a z-star value of 1.2816. So first thing we need to do is check conditions, which actually doesn't change as we move confidence level. So as we checked them before, that's going to be the same. So we don't have to check them every time. As soon as you check the conditions once, you're good to go. So that's all good. Then we're going to use our formula again to construct the interval. And the only thing that's going to change is z-star. So you take 0.46 plus or minus 1.2816 times square root 0.46 times 0.54 over our sample size of 166. So now we're just going to adjust that right-hand side with our new z-star value, which will be 0.0496. So we're going to split into the subtraction and the addition. So if we take 0.46 minus 0.0496, we'll have a 0.4104. And if we take the addition between those two values, we'll get an upper bound of 0.5096. So our wording is going to be very similar, but what's changed is our confidence level and the actual interval. So we'll have with 80% confidence, (41.04% to 50.96% of US adults were baseball fans in 2012. So this example shows the steps you need to go through in making a confidence interval and kind of the extra steps that are outside of just constructing the interval. You always need that sentence conclusion with them. But what I also want to show with this example is how the confidence level has an effect on our intervals. So let's compare the two intervals that we got out. In the first one, we were going from about 36% up to about 56%. So let's even write that down. About 36% all the way up to about 56%. And in the second one, 41.04% to 50.96%. So we're 41% to 51%. Now in terms of width of the interval, like if you imagine putting these numbers on a number line, kind of finding the distance between them, they have different distance. In fact, this has a large width to it, going from 36 to 56. That's about 20% distance that it's covering there. So that interval has a pretty large width to it. Whereas going from 41% to 51%, now we're only covering a distance of about 10%. So this has a smaller width to it. And that's all based on the confidence level. So in that first example where I want to have 99% confidence, I basically want an interval that says I'm 99% certain that population proportions between those two values. But to be so confident that the value is landing in there, I want to have kind of a large range for my interval so that it's more likely to be landing in there. Whereas when I bump down to 80% confidence, I'm less confident, so I'm kind of less worried about my population proportion actually being between the two values, so it can create a smaller width. So this idea gets to certainty versus precision. So precision is kind of like, how sure are we that this population value is landing in there? So with this first question, what happens to the size of the confidence interval, or you could think of the width of the interval, the more certain you are. So as we up our confidence level, the interval is larger. And as we become less certain, as we lower our confidence level, this interval can become smaller. And a good metaphor for this is fishing. If you're going on a fishing trip and you want to say, I'm 99% sure I'm catching a fish today, if you had choices of different types of nets you could use for fishing, if you want to be 99% sure of catching a fish, you'd probably want to get a huge net. You'd want this big net in order to be sure that you catch a fish. However, if you're going fishing and you're not that enthusiastic about it, say you're going into it saying, you know what, I'm like 20% sure I'm going to catch a fish today, you'd probably go for a smaller net. You wouldn't need to go as far because you're less sure of catching the value. So that's how our confidence level can affect our intervals in terms of how far are they spanning on the number line.